And I can tell you specific scenarios. I have my own. You're not really a fully trained cosmologist unless you have your theory of either where the universe came from or where it's going. And I think that the best way to look at it is probably there was a pre-existing parent universe, and we are an offspring. We are a baby universe from that pre-existing parent. The pre-existing universe was perfectly empty, but because of the influence of vacuum energy, which we now think we've detected the influence of, there's tiny quantum fluctuations, which means that even empty space is not perfectly stable. Even a universe with nothing in it can have a little, very unlikely, but inevitable in an eternal universe, event that gives rise to a whole new universe. And I would even argue, if I had much more time, that this is an explanatory theory because it explains features of our post-Big Bang universe that are extremely hard to account for otherwise, such as the arrow of time and other things that we observe about it. And I need to add a word of appreciation to this beautiful chapel that we're holding the event in. I just hope that somewhere in the middle of my talking, the roof does not fall on my head. But if it does, that would be evidence, and I would update my beliefs accordingly. I also want to... I once co-taught a course on the history of atheism, and both me and my co-teacher were atheists, so we thought, to be fair, as a guest speaker, we would bring in a non-atheist. And we invited Father William Buckley, who was a Jesuit priest at Boston College and the author of the best scholarly work on the history of atheism. And he came and he gave some great talks. He was an alumnus at the University of Chicago. And at some point, as we're talking, he puts his arm around me and says, "Sean, you don't think that I believe in G-O-D, God, do you?" So, I'm suspecting it is possible for Catholics to be atheists as well. And the word God is fraught with all sorts of things that I don't understand. What does it mean, and what is the role played by God as an unmoved mover, as an Aristotelian first cause, God as a necessary being? Very often if you ask theologians, how would the universe be different if God did not exist, they will say, I cannot imagine a universe in which God does not exist, therefore I cannot answer that question. To me, as a scientist, there's a huge problem right from the start with this kind of reasoning, which is that it is the whole strategy is one based on some a priori metaphysics. That is to say, this is, very much armchair philosophizing in the best sense of the word, sitting down, thinking about all the possible ways the world can be, and concluding that those ways must somehow involve the idea of God. There's no step in that process in which you actually go out and look at how the universe actually is. You don't need to in this way of thinking about it, because you can just argue logically that God must be part of the universe. It is my firm belief that this kind of reasoning has never taught us anything true and interesting about the actual world. That is not to say that armchair thinking without going out and looking at the world is not useful in any way. It's extremely useful. Mathematics, logic, other branches of philosophy and formal inquiry are not empirical in nature. They don't involve going out and looking at the actual world. They reason in an a priori sense, but they also don't reveal interesting truths about the actual world. Mathematics reveals consequences of axioms. You say, I have a certain axiomatic structure and I derive theorems on the basis of that. It doesn't tell you which axioms are possibly true. If you want to actually figure out our universe, does it involve some notion of God, that is an actual fact about the specific universe in which we live. And I personally don't think that this a priori kind of reasoning is ever going to get us there. We actually understand the future of the universe better now than we used to. Not only was the universe expanding in traditional Einstein cosmology, but we didn't know what would happen in the future. Maybe it would expand forever, but maybe it would recollapse. Maybe the evolution of space-time would stop expanding. The gravitational force of galaxies would pull them together. And then you would have a big crunch in the future, which was kind of nice. It was a pleasing symmetry. Einstein himself liked this idea because the entire history of the universe would be in finite duration. It came into existence, it went out, a few billion years, and that was all she wrote. These days, we are increasingly skeptical that that is the future of our actual universe. And the reason why is because we've looked at the universe once again, and we've seen that not only is it expanding, but it's accelerating. The galaxies that we see in the universe show no signs of slowing down and coming back together. They are moving apart faster and faster. And we have models to explain this involving dark energy, but even though the models are not firm, they tend to make you think that what will happen in the universe is that it will expand forever and ever. The future of the universe is an increasing story of dilution and cooling off and getting emptier and lonelier and slowing down, leaving you with empty space. If that is true, and it's by no means established, but at least seems very plausible if not likely, then you have this weird asymmetry between the end of the universe, which goes on forever, and then the beginning. Why was there a beginning at some point if the future goes on forever?
Here's a photograph from the Hubble Space Telescope of a few hundred out of the hundreds of billions of galaxies in our observable universe. The theistic explanation for cosmological fine-tuning asks you to look at this picture and say, I know why it's like that. It's because I was going to be here, or we were going to be here. But there is nothing in our experience of the universe that justifies the kind of flattering story we like to tell about ourselves. In fact, I would argue that the failure of theism to explain the fine-tuning of the universe is paradigmatic. It helps understand the other ways in which theism fails to be a better theory than naturalism. What you should be doing over and over again is comparing the predictions or expectations under theism to under naturalism. You find that over and over again naturalism wins. And I'm going to zoom through these. It's not the individual arguments that are important, it's the accumulated effect. If theism were really true, there's no reason for God to be hard to find. He should be perfectly obvious, whereas in naturalism you might expect people believe in God, but the evidence to be thin on the ground. Under theism, you'd expect that religious beliefs should be universal. There's no reason for God to give special messages to this or that primitive tribe thousands of years ago. Why not give it to anyone? Whereas under naturalism, you'd expect different religious beliefs inconsistent with each other to grow up under different local conditions. Under theism, you'd expect religious doctrines to last a long time in a stable way. Under naturalism, you'd expect them to adapt to social conditions. Under theism, you'd expect the moral teachings of religion to be transcendent, progressive, sexism is wrong, slavery is wrong. Under naturalism, you'd expect that they reflect, once again, local mores, sometimes good rules, sometimes not so good. You'd expect the sacred texts under theism to give us interesting information. Tell us about the germ theory of disease. Tell us to wash our hands before we have dinner. Under naturalism, you'd expect that sacred texts to be a mishmash, some really good parts, some poetic parts, and some boring parts and mythological parts. Under theism, you'd expect biological forms to be designed. Under naturalism, they would derive from the twists and turns of evolutionary history. Under theism, minds should be independent of bodies. Under naturalism, your personality should change if you're injured, tired, or you haven't had your cup of coffee yet. Under theism, you'd expect that maybe you can explain the problem of evil. God wants us to have free will, but there shouldn't be random suffering in the universe. Life should be essentially just. And at the end of the day, in theism, you basically expect the universe to be perfect. Under naturalism, it should be kind of a mess. This is very strong empirical evidence. Now, I know what you're thinking. You're thinking, but I can explain all of that. I know you can explain all. So can I. It's not hard to come up with ex post facto justifications for why God would have done it that way. Why is it not hard? Because theism is not well defined. That's what computer scientists call a bug, not a feature. Immanuel Kant famously said, there will never be an Isaac Newton for a blade of grass. In other words, sure, you can find some physical explanation for the motion of the planets, but never for something as exquisitely organized and complex as a biological organism. Except, of course, that Charles Darwin then went and did exactly that. We can paraphrase Dr. Craig's message as saying, there will never be an Isaac Newton for the cosmos. But everything we know about the history of science and the current state of physics says we should be much more optimistic than that. Thank you.
Despite what some of my cosmology friends may have been telling you, it is very, very possible, maybe even plausible, I would argue reasonable, to imagine that the universe has always existed, did not come into existence at what we call the Big Bang. And the relevance of this, one of the relevances of this to this particular conversation we've been having, is that the question of the origin of the universe is what we call a gap. It's one of those parts, one of those questions we're faced with in our attempts to understand the universe in purely rationalistic terms, where some people are tempted to blink and say, you know, that's something that your science is never going to understand, the absolute origin of the universe. We need to invoke the help of this guy. This story that we told you that convinced you there was a Big Bang is not internally consistent. We have theorems within Einstein's general theory of relativity, within our understanding of classical gravity, that given the conditions of the universe now, there must have been a singular point, a point where the universe was infinitely dense and had infinite space-time curvature, and we can even tell you when it was. It was about 14 billion years ago, and we even have data that tell you what it looked like 1 second after the Big Bang. However, these theoretical demonstrations using classical general relativity can't be right, because this infinite point of singularity means that general relativity is not correct at that point in the universe's history, and nobody thinks that it is correct. What actually has to happen is that some better theory has to come into play before you hit this singular state. Normally we think it's some quantum theory of gravity that we haven't yet developed. But the point is, all of our firm declarations that there wasn't anything before the Big Bang are based on a theory that doesn't apply at the Big Bang. So let's think hard about what could be right. We don't know yet the answer, but if you imagine trying to understand how quantum mechanics would change our notion of the early universe, it is more plausible than not that there was something before the Big Bang, that there was some pre-existing space and time from which the Big Bang evolved. The Big Bang was an event in the history of the universe, not the beginning of it.
The nice thing about the universality of gravity is it gives us a way to inventory the universe. You can find, with quite good confidence, everything that there is in the universe, whether or not you can see it, if you map out the gravitational field everywhere in the universe. Everything responds the same way to gravity, and everything creates a gravitational field in the same way. So if you map out where the gravity is, you found all the stuff in the universe. For example, you can do gravitational lensing. Since gravity affects everything, it affects the path of photons moving through gravitational fields. So if you have a quasar in the background and a galaxy in the foreground, the light from that quasar will be deflected passing by the galaxy, and the amount of deflection you observe tells you how strong the gravitational field is. That in turn tells you how much stuff there is in that galaxy. So you can weigh that galaxy just by looking at the amount of deflection from the quasar behind it. So I can't go into details because we want to get to other stuff, but this kind of technique has been applied all the time, and you get a consistent answer. What you get is, for example, this is a cluster of galaxies. This is a computer reconstruction from data. This is not a model. These orange dots are where the galaxies are. The blue is where matter is that is not accounted for by the ordinary matter that we know and love. We have very good limits from Big Bang nucleosynthesis as well as direct counting on the total amount of ordinary matter in the universe. It is not nearly enough to account for the gravitational fields in galaxies and clusters of galaxies.
Thanks, John. It's a pleasure to be here defending such a cheerful and uplifting proposition as death is, in fact, final. Driving around the streets of Los Angeles, where I live, you can't help but notice these gigantic billboards telling us, "All men must die." It turns out they're advertisements for Game of Thrones, but I thought that they were advertisements for our event here tonight. It's a similarly, not quite as happy message as we might like to accept. Fortunately, we can open Dr. Alexander's book. It begins with a quote from Albert Einstein. Einstein says, "A man should look for what is, not for what he thinks should be." To which I would like to reply, exactly. We human beings are not always perfectly rational. Let me tell this shocking news to you. We are bundles of cognitive biases, and one of the strongest biases we have is that we go easy on propositions that we would like to be true. What we should, in fact, do is go especially skeptical on propositions that we would like to be true, and even I want it to be true that death is not final. But we should hold something like that to an extraordinarily high standard of evidence. So what are we actually being asked to accept? What should we expect the world to be like if death were not actually final? For one thing, I would expect that the existence of souls persisting in the afterlife should be perfectly obvious. It should be just as clear that heaven exists as it is clear that Canada exists. But in fact, it seems that the souls persisting in the afterlife are kind of shy. They don't talk to us, except sometimes they do talk to us. I would expect also that when people did have near-death experiences and really talk to other souls in the afterlife, that they would come back with consistent, interesting, non-trivial stories to tell. But in fact, when Christians have near-death experiences, they often say they've met Jesus. When Hindus have near-death experiences, they meet Hindu deities. There was a little girl who had a near-death experience, and she met a portly man wearing a red cap. She met Santa Claus. And we are told by some defenders of this that, well, Jesus dressed up as Santa Claus so as not to scare the little girl. Possibly that is true, but we should be asking, are there other plausible explanations? I especially think that if we went and had life after death and then came back to visit us, bringing some message back, that message should be as useful as possible. We are told that, people have after-death experiences and they come back saying, you know what, love is really important. I agree with that, but actually I knew it already. What I would like to know is a cure for Alzheimer's disease. What I would like to know is something that I didn't already know brought back to us, but it seems that the souls in the afterlife tend to speak in platitudes. The story that we're told of life after death doesn't really hang together. What we have are personal testimonies, like that from Dr. Alexander. So people say with very sincere voices that what they experienced was totally real. And I have no doubt in the sincerity of this testimony. What I'm asking is it possible that our brain is telling us that something was real, but that thing does not actually correspond to something that really happened? And when you ask it that way, the answer is obviously yes. Our brains are fooling us all the time. Steve Novella, my partner, will tell us about the neuroscience behind this, but basically our brains are not like video recorders or photo albums. They're more like little theaters. When we try to remember something, it's much like imagining something that hasn't happened. It's more like running a script than reviewing a tape. And that's why when we dream, when we hallucinate, when we have a near-death experience, it is just as vivid as something that actually happened. In the legal community, they will tell you that eyewitnesses who tell you that have a certain sincerity and conviction that their eyewitness testimony is true, that conviction is essentially uncorrelated with how true it actually is. The vividness or reality of a memory does not tell us that it was really real. So what is going on? We had this informal idea that there is a soul that sort of is a blob of spirit energy that takes up residence near the brain and drives us around like a soccer mom driving an SUV. But we've known for a long time that this picture doesn't make sense. Back in the 1600s, Princess Elizabeth of Bohemia carried on a correspondence with René Descartes, who was trying to defend mind-body dualism. And Elizabeth demanded to know, how could something immaterial like the soul affect something material like the brain or the body? Descartes was never able to answer that question, and these days science has gone way beyond that. We know a lot more about what is happening. We can literally see memories being formed. We can see the chemical changes in neurons. So the soul is supposed to also have memories. How do the memories get from the neurons to the soul? We know that brains often have false memories in them. Does the soul in the afterlife carry those false memories, or are they somehow corrected after death? We even know the laws of physics by which the atoms, the electrons, the elementary particles in our brains behave. We know the equations that the electrons that are responsible for chemistry obey. And there's no ambiguity in these equations. They could always be wrong. It is always possible to say, well, we just don't know what is going on. That's fine. But what we have is the evidence of every experiment ever done telling us that these equations are correct. To overcome that, we would need very, very strong evidence. Just one experiment telling us how the soul is pushing around the chemicals in our brain, but we don't have that. What science says is that life, or consciousness, is not a substance like water or air. It is a process like fire. When you put out the flame on a candle, the flame doesn't go anywhere, it simply stops. And that is what happens when we die. So we're faced at the end with two scenarios. One scenario says that everything we think we understand about the behavior of matter and energy is wrong, in a way that has somehow escaped notice by every experiment ever done in the history of science. And instead, there are unknown mechanisms that allow information in the brain to be transferred to blobs of spirit energy that persist after we die and can talk to the other blobs of spirit energy, but don't talk to us, except sometimes they do. The other scenario says that physics is right, and that people under stress sometimes have experiences that are not actually real. On the basis of rationality, it is not a difficult decision to choose between these two options. On the basis of emotion, it might be difficult, but we need to have the courage to live life here in the actual world. Thank you.
Thank you, Sean. Carroll.
What do we know about dark energy? It's not that we know nothing. We do know certain things. Dark energy must have certain properties to explain the data that we have. For one thing, it has to be smoothly distributed. It can't be collecting into galaxies and clusters, or we would have detected it through gravitational lensing, but it wasn't there. It has to have constant density, or nearly constant density, and that's what makes the universe accelerate. Ordinary matter and radiation dilutes away as the universe expands, but Einstein's equation says that the space-time curvature, which gets a contribution from the expansion rate, is sourced by energy and momentum. So as the universe expands, matter dilutes away and the universe slows down. Dark energy stays constant in density, 10 to the minus 8 ergs per cubic centimeter, even as the universe expands. Therefore, it gives a constant perpetual impulse to the expansion of the universe, and that manifests itself as acceleration. Finally, it's invisible to ordinary matter. We don't see it. It is dark. This is a picture that I took in my laboratory of a little cubic centimeter of dark energy, but it is a false color picture. Really, the dark energy is completely invisible. It's just the answer to the question, if you took 1 cubic centimeter and removed from that cubic centimeter everything, removed all the particles, all the dark matter, all the radiation, all the ordinary matter, so that it was empty, and you asked yourself, what is the energy contained in that empty cubic centimeter of space? The answer has no reason to be zero in general relativity. It's a constant of nature. It is the energy density of empty space, sometimes called the vacuum energy. The vacuum energy would be absolutely constant and is the leading candidate for what the dark energy could be.
Life after death. And I've heard very good atheists and humanists say, well, we don't know about this life after death thing yet because we don't have data. If you believe the quantum field theory is correct, and you want to believe in life after death, there has to be some way for the information about your immortal soul to be carried outside your body and to hold together in a coherent way and then land in some other organism at some other time. There's no way. There are no particles of which your soul could be made. There are no interactions that could carry that information away. We don't need to worry about this question. We know the answer. Knowing some of the fundamental rules by which nature behaves has implications for the larger picture.
You see, here's a bunch of galaxies, but the gas is displaced over to the right. Here's the other bunch of galaxies, and there's this shock front here, and the gas is displaced a little bit to the left. What happened is, not too long ago, cosmologically speaking, these two clusters collided and went through each other. The galaxies are just like test particles. They just went right through. But the gas didn't go right through. The gas in one cluster smacked into the gas in the other cluster. The shock wave was formed, and both of the globs of gas were stripped from where the galaxies are. So most of the ordinary matter in the bullet cluster is not where the galaxies are. It's where that gas is, which is in a different place. This lets you ask the question, is the gravitational field in the bullet cluster due to the ordinary matter, or is it due to something else? If you don't believe in dark matter, you can believe that gravity falls off with the different force law, but you still need to believe that gravity points in the direction of the source. Gravity points in the direction of where the matter is. So if you believe in modified gravity as an explanation that would get rid of dark matter, the gravity should be where the red stuff is, not where the galaxies are. Now you can use your gravitational lensing trick to figure out where the gravity is. You can look at the tiny distortions of galaxies in the background of the bullet cluster to map out the gravitational field, and here it is. You find that the gravitational field of the bullet cluster lies smack on top of where the galaxies are. The ordinary matter doesn't. There's a clear displacement between the gravitational field and the ordinary matter. This is exactly what you would expect if most of the gravity in the cluster is caused by dark matter particles that do not collide, that have no dissipation. When the two clusters go through each other, not only are the galaxies going through each other, but the dark matter goes right along with them. So if the galaxies and the dark matter are sitting right there, that's where the gravity is. The matter, the ordinary matter, the hydrogen and the helium, is sitting somewhere else. This is not to say that Einstein is perfectly right in every way, but what is to say is that dark matter really does exist. The only way to explain this picture is to invoke invisible, collisionless particles, then there's many more of them than we can account for in the standard model of particle physics, and you call that dark matter.
Here's the sketch of this idea, and now this is totally speculation land, so I don't want you to completely believe this, but this is the kind of direction in which we need to go to try to explain what the universe should be like. The idea is that in this empty space with just a little bit of energy, these quantum fluctuations going on, very rarely but every once in a while, one of these fluctuations will make a new universe. That in a little region, you will fluctuate space and time into a teardrop shape that pinches off from the rest of the universe, and you make what is called a baby universe. It's easier to make small baby universes than to make big ones. You can imagine that sort of small baby universes require less of an unlikely fluctuation than having a billion light year across universe. So you make this little tiny bubble of space-time, and guess what? It expands. And the best way to make it expand is if it has this energy in it that doesn't go away, this dark energy stuff, that makes it expand more and more. And that happens, and then if you wait long enough, that dark energy decays. Just like an ice cube melts, an ice cube goes from being solid to liquid, that dark energy can go from being dark energy to matter and radiation. And there's a lot of energy there, so it's matter and radiation, really, really hot, really, really the same in different places in the universe. So what does this sound like? This sounds like our universe. This sounds like the Big Bang. So in other words, putting it all together, we have empty space, fluctuations because of quantum mechanics that we absolutely can't get rid of. It's a prediction of the theory. Occasionally, these fluctuations make a new universe. This universe starts hot and dense and smooth and grows up and cools off and becomes empty space itself and lasts that way forever. But it doesn't just happen once, it happens again and again. So in other words, the universe, which we started off empty space, nothing going on, can't sit there forever quietly. There is no way to keep the universe well behaved all by itself. It's just an implication of quantum mechanics. It keeps making new universes, and the way it makes new universes is to start them small, hot, and dense like ours is. The idea is that we are a baby universe of some quiet, unassuming universe that came before.
You know, when we're 6 years old, we all care about this stuff, right? Kids know that the universe is an interesting, fascinating, exciting place, and they ask questions. Why is it like that? And so I'm not saying that we should invent some new passion for understanding the universe. We should just remember that we do care about it. It's kind of beaten out of us when we go through high school and get jobs and things like that. I think that everyone should share in the passion of figuring out how stuff works. I think there should be a lot more emphasis on the method of science, the way that we figure things out, rather than just on the facts that we get at the answers. I think that in the modern technological era, we can be able to use the internet and video games and all sorts of wonderful ways to teach people the puzzle-solving skills that make them think like scientists.
Why is it important for us to think like scientists?
Well, we live in a world that's governed by science, right? Not only the physical world that obeys the laws of nature, but our social world, our human world is extremely influenced by science now. It is the best lens we have with which to view how the world works. And I think that everyone should play a part in figuring that out. There's no reason why, even if you're not a professional scientist, you can't follow along with what science is doing. I think that I want to live in a world where after work, people get off a long day at work, they go to the bar, they have a drink, and they talk about their favorite interpretation of quantum mechanics.
Nobody ever confuses time with space. Okay? You might be driving around a neighborhood that you don't understand very well, and you might make a left turn where you wanted to take a right turn. No one ever makes a wrong turn into yesterday when they wanted to go to tomorrow. So time is clearly not exactly the same as space. And so what is it? What is this difference? Why do we never have the danger of mixing up time and space in our everyday lives? Well, there's many different reasons, different answers to that question, depending on how deep you want to go. But the basic difference is that time, unlike space, has a direction. Space does not have a direction, but time has what we call an arrow. There's an arrow pointing from the past to the future. In fact, some people talk about lots of different arrows of time, and that's a little bit confusing. There's really one thing going on that gets manifested in many, many different ways. We remember yesterday. We do not remember tomorrow. I hope no one in the room remembers what is going to happen tomorrow. We are born as young people and we grow older. No matter what you might have seen in the curious case of Benjamin Button, in the real world, everyone ages in the same direction. So as a scientist, we want to understand this uniformity of our experience. Causes precede effects. We start young, we grow old, we accumulate memories. We have a feeling that we pass through time from the past into the future. So we would like to explain that scientifically. There's no arrow of space. There's no direction that points out in space, but there is an arrow of time. And why is that? My personal view is that religion does need to talk to science. Science does not need to talk to religion. And the reason why is because science is right and religion is not right. And I say that as someone who is very willing to admit that, 1,000 years ago, I probably would have been a theologian myself. That was the right way to approach big questions of meaning and how the universe works. But in the last 500 years, since the scientific revolution, we've learned a lot through science about how nature works. And we've learned enough to say that God and spirituality don't play a role in how the universe works. So science can offer things to anyone who wants to know more about nature at a very deep level, and that includes religious people. But I don't think that science is going to learn anything by talking to religion. If science teaches us anything, it's that we are not permitted to make demands about how the universe is. So we are not permitted to say there must be an answer to this question or that question. We can hope, we can aspire, and we can say, let's go look for the answer. I'm all in favor of that. But if you say a priori that without leaving your chair, you can figure out through pure thought that there must be an answer to that kind of question, then you're making the famous mistake that you shouldn't make and science teaches you to avoid. There's two corollaries that you might be tempted to draw, both of which I think are false. One is that, therefore, we should turn to religion to address questions of ethics and morality. Or number two, ethics and morality are simply impossible in a world without God or anything like that. I don't think that religion is of any help to ethics and morality because religion starts with a certain understanding of how the world works, an understanding which I don't think is right. So religion gets credit for addressing questions of meaning, but there's no justification for the choice that it makes.
No antecedent on which it is based.
There's no reason why to say that a religious understanding of a certain question gives us the right answer. It attempts to answer the question, which is great. I think that it's important for human beings to address questions of purpose, meaning, ethics, morality. And I would completely agree that secular reason, broadly construed, has kind of dropped the ball on those questions. That it used to be that religion both helped us understand how the world works and gave us a bigger context in which to talk about meaning. Science has removed the need to appeal to religion where it comes to the world, so that leaves us saying, well, what about all those other questions? I'm saying over and over again, science does not create meaning and purpose. Science tells us that out there in the world there is no meaning or purpose to be found. But logically, that does not mean there's no meaning or purpose. It means it's not out there in the world. That means that if there is to be meaning and purpose, it is to come from inside us. Not from science, because science doesn't care what's inside us. Science tells us what happens in the world. We create it. It's a fundamentally creative act. It's not an act of discovery. The creation of meaning and purpose is more like telling a story or painting a picture than doing a science experiment. What amazes me is that putting this story together starts with an ice cube in a glass of water. We want to understand why ice cubes melt and don't unmelt. We want to understand why you can take eggs and make scrambled eggs. You can't take scrambled eggs and make an egg, okay? And the logic of trying to understand how that works leads us to believe in a multiverse. I'd be very, very happy if we came up with an even better explanation than the multiverse, one that was a little bit more tangible and easy to touch, but we're not there yet. Right now, I think that this is the best explanation we have. And it amazes me just as a great lesson that we are part of the universe, that we are not separate from the laws of nature and all the stuff around us, that the features that we enjoy of being in this room, living our everyday lives, depend on things that happened 14 billion years ago. So I hope that once we do understand it better, just give us 2 or 3 years, we'll get it all figured out. We'll be able to come and put the entire story together and make some more predictions and learn more about the laws of nature. Thank you. I think there's plenty of room for meaning and purpose in worlds that are just governed by the laws of physics. I think that the common mistake that we tend to make is that we're used to meaning or purpose being imposed from outside. And we could say very similar things about morality or beauty or other judgmental kinds of questions. And according to the laws of physics, there is no outside to impose any meaning or purpose. The universe doesn't care what we do or what we succeed in doing. But that doesn't mean that I don't care. So I have no problem whatsoever imagining that meaning and purpose are things that we human beings invent. The analogy I like to use is like saying, it's as if someone came up to you and said, oh, you can't paint on that canvas because no one has drawn lines with little numbers telling you what colors go there, right? Of course, if you had the lines and the colors given to you from outside, you could do the paint by numbers, but that doesn't prevent you from creating a great work of art. I think that meaning is one of the words that we use to describe what happens in the universe. In other words, I wouldn't say that you're making a mistake if you chose to describe our universe using vocabulary that had meaning nowhere in it. If you just talked about physics, if you just talked about atoms and molecules and particles bumping into each other, that would not be wrong, but it is also not the only way to talk about our universe. We know that we can also talk about the universe in terms of people and planets and macroscopic objects, thermodynamics rather than statistical mechanics. So my argument would be that the vocabulary of meaning and purpose is a vocabulary of talking about the same stuff that we're talking about when we do physics, but talking about it in a very different way, a way that is more relevant to certain other concerns that we have. We are trying to think of meaning and purpose as like separate kinds of things that you have to add to the universe, but that's exactly what I'm saying is not true. I think that the people who try to say there's no meaning, there's no purpose, there's no free will, for example, they would be on equally strong grounds to say there's no temperature, there's no heat, there's no entropy, because these are just descriptions of